Welcome to the City of Mississauga's instruction video on how we inventory, inspect, and log deficiencies for the public sidewalk network. The sidewalk network is a portion of the larger scope pedestrian transportation network, which includes sidewalks, trails, bike paths, and on-road bike lanes. The city needs to keep an accurate inventory and condition status of its thousands of kilometers of sidewalks to be able to state that we are meeting Provincial Minimum Maintenance Standards and to proactively mark and repair serious trip hazards throughout the sidewalk network. The City of Mississauga has invested a great deal of time and money in establishing procedures and maintaining critical infrastructure. The geomatic section within the Transportation and Works Department is responsible for the maintenance of numerous layers of information, from aerial imagery, property and 1 to 2,000 scale topographic mapping, utility networks, to zoning and land use, etc. The section manages close to 30 discrete themes of data on behalf of the entire organization. The city also leverages its software and is currently subscribed to Bentley Systems Incorporated Enterprise License Services. This gives the corporation an unlimited use license for most products owned by Bentley Systems Incorporated.
Panasonic CFH2 is a fully rugged device. I'll start it up by pressing the button for a couple of seconds, and I'll give you a quick tour of the capabilities of the machine. First thing to notice is it has a light sensor, so it auto dims the screen. It has programmable keys. CFH2 has dual hot swappable batteries on either side. They can be removed at will and replaced for full day operation. It has an Intel i5 core processor with 4 gig of memory, 320 meg hard drive. It has integrated GPS, camera, barcode reader, and Gobi modem. The unit has a multi-touch screen. You can also use the stylus. Use the tip of your finger, the rubber tip of a pen, and if you have a glove, the unit will actually sense through a glove. The barcode reader is located at the bottom. At the back we have the strap, hand strap, and the camera, integrated camera.
The city developed an application, a wrapper, around MicroStation V8i Select Service 3 using Visual Basic for Applications. This application simplifies the MicroStation interface such that the tablet computer is very easy to learn and use. The interface is focused only on the needs of the particular asset being collected and inspected. MicroStation has direct support for the GPS and reads all of our geo-based files natively and efficiently. As we develop the application, we have full control over adding extensions to new asset classes. The changes can be made quickly, borrowing most of the programming code from one asset type or another. The user signs into the tablet computer using their proper credentials. This information is tracked and stored in a local database and used to populate the operator attribute for work performed during the work session. The user clicks the Sidewalk Application desktop icon and waits for the application to load. Once loaded, the application guides the user in a sequential step-by-step process. In the simplest of terms, the user ensures that the GPS is tracking properly. He or she can then start tracking their movements. The user walks a section of sidewalk and stops at locations where surface conditions are apparent. They identify the type of problem, define the extent of the problem, take pictures of the deficiency, and then accept the record. The system continually logs their progress throughout the day and leaves a trail so staff can see what sidewalks have been inspected. When an irregularity is discovered, the system places a green dot at the location of the problem and references the images and the nearest address to the actual problem. A detailed record is created for each deficiency that is logged. This process continues until the day's work is done and the information is synced back at the office. Supervisors have the ability to visualize all work performed. They have a separate interface deployed to their personal workstations. Reports can be run that filter conditions and types of problems so that the most critical can be viewed and work orders sent to crews for repairs. A detailed review of the field process follows. The supervisor interface is showcased near the end of the video. A generic interface links a number of infrastructure inventory applications. When started, the user must select the asset type they are doing inventory and inspection work on. In this case, the user selects the Sidewalk button. The system initializes the GPS module and shows the user the distribution of satellites and their respective signal strengths. When the user gets the green light to go ahead, they can collapse the GPS window and can then select the Start Tracking button. The window will center at their current location once the Start Tracking button is selected. The application logs satellite data and stores points every 2 seconds. If the user is static, that means they're not moving, the points do not get stored until they get on the move again. As they move, the screen recenters itself and displays a yellow line showing their progress. The icon at the center of the screen is an arrow. It always shows the direction of travel. The user may select Stop Tracking at any point. When the system isn't tracking, the user does not leave a trace line behind and cannot log problems. Staff will generally use the Stop Tracking for regular breaks or when they walk back to their vehicles after completing work on a section of sidewalk. To continue working, the user must reselect the Start Tracking function. When the sidewalk inspector finds a reportable problem, there are many types. They simply stop walking, select the Report a Deficiency button, and follow the prompts. The person must first classify the type of problem. Once classified, the user is presented with further refinements of subtypes of classification. Once the problem type has been defined, the user is then asked to detail the number of bays or slabs that are impacted. The inspector marks the issue in the field. Usually this is done before logging the problem. They have a belt with a ruler and cans of fluorescent orange paint used to mark the problem on the sidewalk. Most problems consist of trippers that are less than 2 centimeters in height. Marking these problems with paint in the field is sufficient to meet Provincial Minimum Maintenance Standards. Once the number of bays impacted have been entered, the user is then instructed to take 1 or more pictures of the problem. They simply use the rear-facing camera, point and shoot, and accept or reject the image. The images are stored on the system and are downloaded to a server at the end of the day. The user has 2 final choices to make before they can save or reject the record. They must select the nearest address node so that repair crews can find the problems quickly if they do not have tablets themselves, and the final option is to select the coordinate from the GPS when they stop at the surface problem, or are given the option to select the location by pointing on the screen. The pointing option is handy when heavy tree or building cover weakens GPS signals, or if the user needs to move away from the area when filling in record details. Some sidewalks are busy. Finally, when the inspector hits the Save Record button, the application enters the relevant details into a local database, draws a green dot to represent the location of the problem, and goes back into tracking mode and allows the inspector to continue their walk and day's work. This concludes the field section of the video.